When you're dealing with data, it always starts as, well, chaos, just a mountain of raw, messy numbers. So the big question is, how do we turn that chaos into clarity, into an actual valuable insight? Well, today, we're going to unlock the powerful trio of Python libraries that make that whole transformation possible.
And that's really the fundamental question for anyone working with data, isn't it? You get handed this massive data set, this absolute sea of numbers. How in the world do you turn that into a clear prediction or find some hidden trend? It's not magic, I promise. It's just about having the right tools for the job.
And in the Python world, the answer almost always comes down to this core trio: NumPy, Pandas, and scikit-learn. Now, these aren't just three separate tools. Think of them as a team. They form this seamless workflow, where each one handles a critical piece of the puzzle. To really get how they fit together, let's use a little analogy.
Okay, let's imagine we're building a house. In this scenario, NumPy is all your raw materials. It's the bricks, the steel, the concrete. These are the fundamental super high-performance building blocks. Then you've got Pandas. Pandas is your blueprint. It organizes all those materials, it gives them labels, and it lays out a structured plan. And finally, you bring in scikit-learn. That's your specialized machinery, the cranes, the power tools, that take that blueprint and actually construct something powerful, like a predictive model.
So let's start at the very bottom, with the foundation, with our raw materials, NumPy. This library is, and I'm not exaggerating, the bedrock of pretty much all scientific computing in Python. And all of its power really comes from one core idea. At the absolute heart of NumPy is this thing called the end array, which just stands for n-dimensional array. You can think of it as a super efficient grid of elements, but, and this is the key, it has one critical rule. Every single item in that grid has to be the same data type, so all numbers or all decimals. Now that might sound a little restrictive, but that rule is the secret to its incredible speed. To really appreciate this, let's compare it to a regular old Python list. A list is super flexible, right? You can throw in numbers, words, whatever you want. But that flexibility comes at a huge performance cost. By forcing everything to be the same type, NumPy arrays become way more memory efficient, and, for math, they are orders of magnitude faster. It's not even a close competition. So how does it pull off this incredible speed? The magic word is element-wise. See, instead of writing a slow Python loop to add, say, two lists of numbers together one by one, with NumPy, you just add the two arrays. That's it. Under the hood, NumPy uses highly optimized code to perform that operation on every single element, basically all at once. This is the high-performance engine that drives the entire data science stack.
Okay, so NumPy gives us raw, blistering speed, but a grid of numbers, no matter how fast you can process it, is pretty meaningless without any context. And this is exactly where Pandas comes in. It's the blueprint that gives our raw materials structure and meaning.
I mean, just look at this. This is a standard NumPy array. It's fast, it's efficient, but what is it? What do these rows represent? What are the columns? It's just a bunch of numbers, completely disconnected from reality.
And now, bam! This is the power of Pandas. It takes that exact same NumPy array underneath, but it wraps it in a beautiful structure called a data frame, and instantly, our data has context. We can see the rows are dates, the columns have letters for labels, the numbers are suddenly telling a story.
So, this data frame is a two-dimensional data structure. It's basically a table with labeled rows and columns. This thing is the absolute workhorse for data analysis in Python. Honestly, you can just think of it as a super-powered spreadsheet that lives right inside your code.
And here's another critical difference. Remember how NumPy arrays demanded that one single data type for the entire grid? Well, a Pandas data frame is more forgiving. It only requires a single data type per column. And that is a total game changer for real-world data, because it means you can have a column of names next to a column of dates, next to a column of sales figures, all in one clean table. On top of that, Pandas gives you this massive toolkit for data manipulation. You can quickly peek at your data, you can select specific rows and columns just by their names, you can sort everything, and it's amazing at handling messy, real-world problems like missing values. It just gives you all the tools you need to clean, explore, and get your data ready for the next step.
So now we've got our data in a clean, structured data frame, all thanks to Pandas. Our blueprint is ready. It's time to bring in the heavy machinery. It's time to actually build something with our data using scikit-learn.
And the relationship here is just so seamless. Scikit-learn is built to understand and work directly with Pandas data frames. You take your clean, organized data, you feed it into a scikit-learn algorithm, and it just gets to work, finding patterns, making classifications, and generating incredibly powerful predictions.
And scikit-learn is a ridiculously comprehensive toolbox. I mean, it has pretty much everything you need for machine learning. For supervised learning, where you know the outcomes, you've got classics like linear regression. For unsupervised learning, it can find hidden groups in your data all on its own. It even comes packed with all the essential tools for model selection and prepping your data. It's the whole shebang.
So we've seen the raw materials, we've seen the blueprint, and we've seen the machinery. Now let's just put it all together and see how these three libraries create one complete, powerful workflow from start to finish.
I think the best way to visualize this is as a pyramid. At the very bottom, you've got the foundation, NumPy, providing that raw speed with its array object. Building right on top of that is Pandas, which uses those arrays to create our labeled data frames, our blueprint for analysis. And then, at the very peak, you have scikit-learn, which takes those structured data frames and builds sophisticated machine learning models to find those amazing insights. The really crucial takeaway here is that these aren't just three separate tools that happen to be popular. They form a cohesive, powerful stack that has become the industry standard for a reason. Together, they give you a complete, proven pathway to transform that chaotic pile of numbers into a clear, actionable prediction. So, there you have it. The raw materials from NumPy, the blueprint from Pandas, and the powerful machinery of scikit-learn. This is the path from raw numbers to real knowledge. The only question left is, with these tools in your hand, what story is your data just waiting to tell?